So let's discuss about this data integration part, where we are going to discuss the integration between database and our Spark model. So in real time, what can be there? You can have multiple sources, and your job is to do the transformation on that data and then load to the target location. Okay, so you can have multiple scenarios, not a single one. For example, I will go to this notepad and whatever you can have. Let's say you are getting some source data, source files, and that is getting loaded to database. Okay, maybe using API or maybe some other Python services or Java services are loading, or maybe some automation which keep on happening and that is loading the data, your source files data to the database. Now, here you are running your PySpark application and that is doing transformation over this data. And then you are loading this data to target location. Your target location can be either database again, or it can be, let's say, your uh, database. Let me take it here. It can be database, or it can be any of the location where you are delivering as a file. Either let's say CSV, or you are delivering as Parquet, or maybe some other file. Okay, or it can be some other thing, other location in the sense, let's say you are dumping the data to Kafka topic. Okay, anyone has did this kind of work in their original project or real-time work?
Yes.
Okay, so what was your model?
Both from database to database as well, from file to DB as well, and DB to file as
Yes, so
well.
this is very common use case for the data engineering team. Okay, because most of the time our data is coming to the database, that is coming from the source, and then we are expected to do something, and then we are loading to the target location. In most of the scenario, our target location can be same database where we can have a different table, means a different database, different table, but the same system. Let's say you either you are working with Postgres or SQL Server or maybe something else that can be. And the thing is, this can be either your ongoing data, means real-time data, or it can be a scenario for your historical data as well. Historical data in the sense, let's say there are some model, some system where data is not running with the data engineering, means it's not yet migrated to the distributed system, and the data is around some 10 years data, 15 years data, or something else. And now the requirement is to do the analysis on top of that data for some business use cases. What's next? You have to migrate all that data to your Hadoop model. Of course, if you are having some 10 years, 15 years of data, you cannot do altogether. You have to planning for the batch. You can plan for the batch, and with the batch you can take some thousand, or maybe let's say you are planning for some 5 lakhs, 10 lakhs every day or each batch, and then you can plan out that okay, I am targeting for a month or 2 months, and in that 1 month or 2 month my all data should be migrated. Or if that is critical and you have resources availability, then you can plan for even a week as well, that okay, I will be migrating all this data within a week or within 2 weeks, like that. So this is the thing we usually do. And to do this, I believe that everyone has database setup in their system. You have or not? As of now, what you can do here, if you go to my system, what I have did, I have downloaded this dbeaver. You can go normally with any of the database also, but I did for my own purposes because here we have options. If you see, I am having Postgres, SQLite, DB2, MariaDB, MySQL, Oracle, SQL servers, multiple. Okay, if I go to this, you see these many options are there. If I install, it's a kind of means it's easier thing to make a connection with all the things. Okay, so this is what I use, but you can go for any other independently. You can do install and you can work with that. So for my case, I have installed this dbeaver, and then I have downloaded and installed Postgres. Okay, and means and for that after that installation, I set up my username and password, and then I have logged in from here. So this is okay for me. Similarly, you can do if you do not have the setup. If you have already, then it is okay. So this is the credential just I have copied for my remembering. Otherwise, I will forget what I have used. So I have kept it very simple. Username is Postgres and password is password. This is my driver, and this is my local host and JDBC URL. Okay. So two things I would like to share here. One thing is what you do with the database. When you are reading the data from the database, okay, let me first check it out with the Spark, and then we will discuss about that. So here, let me delete it. I will even open a new SQL editor. Okay, now I will go to this, and I have just created a table. In this Postgres, I have learning, and inside the learning, I have employee table. Okay, so I will just take it, select star from. Okay, so this is the data. Now, simply I will be going to my Python here, PySpark, and here I have written one of the small code. So this is my class file. What I'm doing here, I am trying to fetch all the employee data, where my parameter is Spark, JDB, serial, and DB properties. One thing I would like to focus here. Yesterday, I connected with someone. He is into data engineering already. He had received the offer, but his challenge is he knows how to read the file. He knows how to handle the file and all, means everything, but he don't know how to do properly. And that's what we have to focus. Right? Like here, I am saying that okay, fetch all employees data. Simply, I can write Spark SQL Spark.sql and write your Spark queries, whatever you have, right? But that is not a good thing because all the things can't be kind of single lines. You have to bind inside the method functions, and then you can call that either inside the same file, same class file, or you can call from other files as well. Okay, so make always your code readable and make it reusable, make it properly, make it functional, each and everything. Take care of that. So you can relate it with the real time as well. Like here, if you see, I have to fetch all the time employee. I'm not simply writing, okay, select a star from this one. Here is Spark session. So Spark can be singleton. Okay, where you can use for multiple means you can create one Spark session at a plus. Even I can have a separate class file for the Spark utility. There I can have a Spark session, and then wherever I need, instead of creating again and again, I can call that. Then JDBC URL. Of course, we can have a separate file for all the database. If we can, then that's good, because let's say you are having 10 different requirement to read the data from the database. For each of the requirement, why you are going to take care for the database thing always again and again? Not required. See, at the single place we can have, and then we can reuse that. Then DB properties and all. Like here, I have one separate class file. So let's say I am saying DB connect. Inside DB connect, I'm simply giving this is kind of configurable. It should be configurable. Okay, here I have provided hard code. This is not good. We should make it to read at runtime. So whenever we are running, then we can provide the credential. Or it should be reading from some, let's say you are having some secrets and all, and from there it is reading the credential. Then open connection. Inside open connection, I'm giving this, okay, my connection is open now. Using the cursor, we can do whatever we want to. Then execute from the SQL, where I can pass my query as input parameter and params. So this is optional. Okay, you can see none. If you are not providing, then also fine. If you are providing, then also fine. Then here I am doing commits and all, commit and then close, then execute all. If I have to go with this function, then I can do that. Then fetch all, where I'm going with, okay, fetch all. Multiple things are there with the SQL. So here just I have created a few functions. There can be a bunch of functions, okay, based upon the requirement, and we can have a generic. Let's say for the database you are having some 10 varieties for the functions requirements. You can collect all those here, and then if you have multiple different pipelines, you can utilize the same DB class. No need to have always again separate for each one. So that is kind of a good practice for your use case. Okay, then I am going to this one. Was here. Okay, so this JDBC URL. Now, here what I'm trying to do in this function, I am taking this three input parameter. This is for fetching all employee records from the learning and employee table. Learning database. This is my schema name, and employee table into a PySpark data frame. This is employee df spark.read.jdbc, then URL equal to jdbc URL, which we are going to pass at runtime, table equal to this table. Of course, this is not a good practice. I should keep this one also here, like db name, and then I can say table name. Okay, then I can say here, let's db name dot, let me do like this, db name dot table name. Okay, I think this is also not required. db name dot table name, and then employees df count. Just I am checking if count is greater than 0, then only go fetch employee df dot count, get the count, and see here no employee count, no count found. Then return employee df. Then here is for here, this is a different function where we want to fetch the employee by id. Just we want to give a filter. Okay, so here also we need this JDBC property and all, and similarly we are checking if that is existing. If yes, then we are going to pull out that. And here just I'm checking where is employee by ID. Here I have given the database name and table name. So let's say DB name, table name, and let me take it DB name dot table name. Okay, and then just this is the small function here. you can set up your Hadoop things from the environment variable. I have not set up. Okay. So directly I am providing from my class file. But you try to set up from your system all the things. So this will not be required to keep here. This is just additional thing. So I'm doing the setting up for Hadoop environment, and then initializing a Spark session. So as I said, this can be a singleton. So let's say you are having a separate Spark utility class, and there you can have a Spark session, and that you can call all the time whenever it is required. But as of now, this is just a kind of demo. So I have kept it here. But whenever you are planning for the POC, make sure that your database functions are separated in a class, and you can have some Spark utility Spark session altogether. So that will be functioning as a reusable code for you, and you can use that in multiple pipelines. Okay, here as I am using Postgres, so I am providing this Postgres jar as well. And then this is my JDBC URL, because if you go to the function, I have not provided all the details. I'm just calling this as a parameter. This DB name, table name, JDBC URL, properties, and also at the runtime, we have to provide that. Here, we are providing like this, but at the runtime also, you can provide it. Maybe you can have a config file, and from that config file, you can get all these properties, and you have to provide all the things in the config file. Okay. And then here fetching all the employees. So what's here we have to give DB name equal to learning and table name. Okay. So this is for fetching all employees, employee DB, database integration. This is our class name. Then fetch all employee. This is the function. And then Spark JDBC URL. This will fail. Why this will fail? This function will fail or this function will success. If I go here, this is my
It won't
function.
work.
Sorry,
It won't work, Anamik.
why?
Number of parameters is different.
Yeah. And I'm thinking that why this is not taking. Um, why this is coming with switch. Should be taking switch. Let me run this. Anyway, this will fail. But Okay, so here I have to go to the function here down db name, table name, and here also db name, table name. Let's run this. This is having, this is saying table name not found. So let's go here and let's take it as a string, db name, then dot table name. Now run this. So you can see here in Python, this is just for Python, not in nothing for Spark side. We can have the things how you are providing. So these two are different strings, right? So if that is not taken as a normal concatenation, then simply you can bind it as a string, and then we can give that parameter value, en value pair. Okay, so here for the first one, we had tried to simply fetch the data. Okay. This is for fetch the 10 employees from the table. We have this one. This is printing here. Okay. Then for next one, let me first comment out this one. This one, okay. I will be doing this. Now let me run this. So for this function, what it is doing? It is simply reading the data and then this is taking the count. If count is there, then it is printing this one with the count. And then this is returning this data frame. So if you go here, it is giving the complete data frame. How this is giving the complete data frame? We are not printing anything here, right? So if you come down, here we are giving that things. If employee df, then do so. So this is displaying the data. Next, this is for the next function, where we am giving db integration dot fetch employee by id. This is for by id, where you are giving some filter that if id equal to this or id between this and this, then you can have the condition. And uh, here let me check if I have given the proper filter. Okay, so here I'm saying employee id equal to 1. So you can have some ranges as well. You can define it whenever you are writing. Here it should be printing only one record for the second one. If you go here, error fetching employee by ID requirement failed. Driver could not open a JDBC connection. Check the URL. Okay, so is it closing this connection or this database connection is getting disturbed in between? It can be. If that is the case, then again you have to make sure that your function is functioning properly and it should not fail actually. Okay, check the URL learning. So there is some connection with our database one. I think 2 times this is working on the same connection. That's why. So we can make sure that once it is opening the connection and then it is working for the same connect, means with the same connection this is working for all the requirement. And at any case if that is not working, or if you want loop or something else, then if you are closing the connection, then don't forget to reopen the connection again, means reopening and closing, keep on the loop. So error fetching employee ID requirement failed. The driver could not open JDBC connection. Check the URL learning. Some other issue is there. Okay, let me go to this class. I do not see any issue here because all the connections and all we are using the same. Why this is? We are also giving same table names and all, learning and employee, and here we are looking for the table name and all. Okay. Here this is different class, forget about that. Okay, so you can look into this whenever you are working. Fine. Look into this in the sense you have to see why this is failing with the connection. This is JDBC connection itself. Let me run this one. Here also I had the same. Fetching all the data by employee ID. Something else is running. So I want to run this current file. Okay, here it is loading. So I have did something wrong here or missed something. Okay, I had just copied pasted this code itself. So here you can see for the very first function, it is reading all the data, and for here for the second one, it is reading only for the ID one, wherever ID is one. If you look at the ID one, then I can verify from my database this one, RO, right? Department is IT. So this is the thing, and what can be next here? So if you look at this, I was defining one more function. So let's say I am reading from the database and I want to write this as a file. So for that, I have implemented this one, not here in this one. Okay, and here if you see, I was just trying to have a function export to CSV. You can have a function maybe export to CSV or export to Parquet. Okay, and then you are trying to write your files in the destination folder. Then you can have here I want that okay, my file name should be employee data underscore current timestamp YYMMDD, then hour minute second, like that. So like this is going to form the file name, then .csv. You can plan for the same for CSV and Parquet both. So whenever you do the exercise, try to read the data from the database and then write the data as a CSV or as a Parquet or both the files at the same time. You can try out this. Now I will be focusing on the real-time challenge. So real-time challenge is, let's say you are getting the source data every day. Every day you are receiving the data, and this data is having some heavy transformation. Heavy transformation in the sense this is taking lots of time. Heavy transformation, and then you are loading it back to database, or saving as Parquet, saving as Parquet file. Now this is let's say this is a snapshot, means everyday refresh. Everyday data is keep on refreshing. Okay. So every day you are getting the data from the source. Let's say you are getting the data from some APIs using some API sources, and that is getting dumped to your database. That database is keep on updating every day, means refreshing the data. You do not have any historical data, and whatever data you are getting, that is taking lots of time in the transformation, because maybe you have very complex JSON and lengthy JSON file is there. Then of course, if complex JSON, complex transformation, then this will be a time taker. Okay. Every day this is keep on refreshing. So let's say today you loaded 100 records. Means 100 records were loaded from the source and you processed this. And tomorrow again you are loading some 100 records, and out of 100, let's say 102 records. 102 records. And out of 102, 2 records are new. Of course, 2 records are new, right? Because 100 were yesterday as well. And uh, for the remaining 100, let's say 7 are updated. 7 are updated. That means what? You are having total 102 records for today's ingestion, and out of 102, you are having 93 records which are existing records with no update, and 7 are updated, 2 are new. Now, if you are a developer and you have to develop a code, PySpark code, how you will be doing this? Are you going to truncate this data and reload? Okay, truncating is forget about truncating, that is about the source. For the processing one, what you are going to plan? Either you are going to read all the record, either 100 or 102 or 105. For the daily basis, you are going to read all the data and have your transformation. Let's say this is your transformation 1, 2, 3, and like that you are having so many n number of transformation, then you are pushing to target location. What will be your planning for the development phase? How you are going to do, because you have to take care for the optimization. Any idea?
I will read all the data and from target side will insert or update. If new record comes, it will be insert, and if existing record with others, then it will update.
No, that is updated, that is okay. But the thing is, uh, in the same table yesterday there were 100 records that you have already processed. All the transformations are done for that. Today you received 102 records from the source. Okay, let's assume that this is kind of truncate table. Every day this is keep on refreshing the table. Okay, in your table you received today 102. Out of 102, 93 is existing that you already processed yesterday. That means there is no changes in the data, and this data is already processed by your application. Whatever you have received today. The difference is 7 records. What you have received today, they are updated, so you need to reprocess, right? some changes are there. And the two records are completely new. That also you have to process. So what is your plan? Either you are going to read the entire data and you are going to process, or you are planning that okay, I will be processing only the new one or updated one. Otherwise, if there is nothing new, nothing update, then I will completely skip my job and I will say there is no updated record. So job is done. Not required because yesterday we already processed, right? Means the same data has been processed. So how you will be
Without
designing?
reading, how can we come to know that there is update or no update? We need to
Huh,
read all the records.
that's the point. That's the point. So see, from the source, this will be keep on loading, right? Now you have to make sure that how you are designing this. So in database, you have option for CDC, change capture data, change data capture, this one, CDC model. Okay. So for whatever data is coming, changing on means capture whatever data is coming, that data is coming with the, some changes, either new data or updated data or existing data. So keep on capturing the change, whatever is. So this is CDC change data capture. Okay, have you heard about this previously? No. Okay, so using change data capture, we can have our design where we can capture all the changes. Two things are there. Either you can do this design with with SQL Server that is integrated. It means Spark. This SQL architecture has been designed in the backend that very easily it can capture and it can do with minimal setups. Only one time you have to create the triggers and functions and you have to run that, and by next time automatically this will pick up. Or if you are working with the Azure and all, there also you have your own function, your own way to do, you can do. If you are working with the Spark and you do not want to work with the SQL, or maybe you are not working with SQL at all, that can be. In that case, you have to write your own function for the same and you have to see how you can capture all the things and then you can take care, because processing all the things, same things again and again, not recommended. Okay. So you have to think about that. Now, if I will go here, this is change data capture. So in Spark and SQL, change data capture refers to the technique used to track and capture changes, insert, updates, and deletes in source data so that they can be applied to a target system. And this helps keep systems synchronized without needing the performance full refresh. Full refresh is not required, because if that you are getting, if you are having some GBs and TBs of data, and as I said, in the real time you can have complex data, complex transformations and all, and unnecessarily why you want to process that if that is not required. If data is not updated, what is the need? How much updated? Just work with that only, right? So in CDC, in Spark, if you want to do that, then you have option for the Delta Lake, where a storage player that enables ACID transaction and handles CDC efficient by maintaining transactions logs. And it provides mechanism like merge into, where changes from a source, either insert or update or deletes, can be merged into a target delta table. So this is the syntax if you are working with the delta table. Now, this is all about the same. Iceberg is also option, uh, one of the option for the CDC, where you can um, have this enable, and then Spark by handling incremental changes over the time, applying them efficiently, and they will be updating the data with the upserts with the time travel queries. Like if means it will be simply comparing with the timestamp for the last process timestamp and the current timestamp. If any changes with the data, then that will be taken care. And if even this will be maintaining data versioning as well. Means that this is the previous version, there this was the data, and this is the new version. Here, this is the data. Then CDC in SQL. If you are working with SQL, then you are having triggers. You can create the triggers and that will be working for you. So these are the database triggers that captures changes, insert, update, and delete in a table and store them in a change log table. And from that change log table, as you said, how you will identify, right? So you can have a change log table, and from that change log table, you can identify which all records are new, which all records are updated. Then you can take care of that. Here, like this, you can create the triggers. Create trigger, trigger name, then insert into either you want for insert or update. You can handle for all three: insert, update, or delete, or you can handle for any one or any two. Not mandatory that all you are going to take care. Maybe in your requirement you are not looking out for delete. Whatever is deleted, you do not want to care. So let's forget about delete. Just care for insert and update only. Or if you want to check only for insert and delete, you do not care for the update. So like that, you can have the combination, whatever is your requirement. And then like this, you can create the trigger, and then you can go ahead with this. So here you have database logs where database provides CDC feature through transaction logs or change tables like SQL Server CDC feature, Oracle Flashback, etc. Then you are having replication. Certain databases support CDC through replication streams, and that is going to allow external systems to capture and process data changes incrementally. So in both his Spark and SQL, CDC about capturing data changes. This is mostly for capturing data changes only. And this is a real time issue. In the real time, you will be having this challenge most of the time, and you have to take care. And the recommendation is that most of the time you are having good amount of data, good volume. So if we can ignore which is already processed, we can ignore. And for that, we have to identify what was updated. And you have to capture all the updates, deletes, insert in the change log table. And from there, we can identify and then we can process accordingly. Okay, now if you want to go with the CDC implementation, then what all you have to do? This is a very simple step. Okay, just we will go one by one. I have captured all the code. You have to just run, copy, paste, and run. So this is first you have to create the main table, then set up a CDC enabled database and create a CDC table, create a trigger or log changes and insert the data and test that. That's it. What we are going to do, create a schema CDC test. Here I have taken. Anyways, I have already one of the schema, so I'm not going to create. Even I will not create database as well. We will be working with the same database. Now, here I have to create one of the table. So let me create this table. I will just copy paste it. Means I'm just assuming that I'm not going to create the database because I have already database. So, or okay. So here, let me take this CDC, change data capture. Change data capture test. I'm going to create a table. In this table, CDC test. Do I have CDC test? This is right. So I will be simply dropping the tables. Let me delete it. Cascade delete. I deleted it. I will delete this table as well. Okay, now I do not have any table into this CDC test. In this database, I am going to create one JSON splitted data. Okay, and this is my column name, event ID, primary key. Then this is with the serial. So this will be taking a number on its own, not like 1, 2, 3, 4. This is auto incrementing. And then parent ID, item ID, file name, collection date, UTC. These are my columns for the table. So let me create it. So this is our main table. Again, if you're working with the real time, table creation is just a one-time work. Always you are not going to create the table. So this is done. In the next step, you are going to do load the data. So we will be loading the data in the same table. So this is about load the data. Let me run this. It's done. Now we can test it. So let me first just run this. Select the star from data is loaded. 4 records are there. Okay. Then we will be seeing how this is keep on updating. Next, I will be taking insert for the second file. So this is for one of the file. I will be inserting one more, means one more time for the. I will be just assuming that this is the second file data, and I will show you how this is. So if you see here, I'm saying parent ID 1, and now I will be inserting the data for parent ID 2. So I'm assuming that these 4 records belongs to a single JSON file. And now I will be inserting which is belonging to the different JSON file. Just assumption. Now I will be testing the data again by running this query. So if you see, these are the parents ID 111, here 2222, and here file name is changed. That means I'm assuming that these 4 records belongs to a single file and these 4 records belong to a single file. So let's assume that you are getting 2 files data from the source and that is loaded into your database. Fine. Next, you can go with this. And this is to verify the table. So let me copy all the things all together in the database. This is separate example, but just I'm simply copying everything. We will process one by one. So we have created one of the table. That table you can verify here. This CDC table, let me refresh it. JSON splitter data, and there we have loaded the records. Means two file records, 8 rows we have been sorted. Just assumption that we are having 2 files. Then this is for verifying the data we already verified. Then create CDC audit table. This is the main table where we are assuming that we are having some data. We should have one CDC table as well. CDC means audit table, and there it will be capturing all the inserts, updates, deletes, and from there we can identify which record was updated, which record was newly inserted, and then we can focus on processing them only by ignoring the existing one where there is no update or anything. So that is not required. We can ignore that. So this is step is for creating one CDC table. I will create the CDC table with the same column, but again column is optional, not required that how many columns you are taking. What you want to handle accordingly, you are going to provide the column name. Here if you see CDC ID I am giving, means I want to capture one CDC ID. Then operation type, what should be the operation type? Either it should be insert, or it should be update, or it should be delete, whatever I want. Then change timestamp, when that changes happened. For that timestamp I want to capture current timestamp. For the CDC event, whenever it is happening, then event ID, and then parent ID. This is from here. This is event ID, parent ID, item ID. So same column I am capturing here. Event ID, this is event ID, parent ID, item ID, file ID. If you see, this is the same. The new watch, CDC ID, operation type, and change timestamp. These are the new columns I wanted to keep in my audit table, CDC table. And using this, I will be good to identify what is going on with the data. So let me create this table as well. Okay, if you see now, I should have 2 tables. Let me refresh. I have 2 tables. One is this one and one is this one. If I do, if I run this table as well, let's say select a star from, just let me drag and drop. Nothing is there, and we are not expected to load anything here because this is the audit table and it should be capturing automatically based upon the main table. We are not going to load anything manually here. Okay. Now, this is the step to create the trigger. Create triggers to capture the changes. Create triggers for each operation, insert, update, and delete. And you have option to have a combined function for all three steps, or if you want to have a separate, you can go with that as well. This is okay. Uh, Anything you can adopt. So here I'm just creating one of the function. So create a trigger function for CDC logging. This function will handle capturing data changes for all three operations. That means I am going to have a combined function, not the separate function for insert, update, and delete. But in the document, whatever I will share, both the examples are there for the separate also and for the combined also. So you can go through both. Here I am taking this one. Trigger function for CDC logic. So what is there? And again, this is one time use case only. One time you are going to create the trigger and function, and next time no need to have it, no need to create it, as it is one time exercise only. Always it will be working with the same. So here, if you see create a replace function, I'm creating one of the function, then return a trigger I have to create where I am just looking out for the insert. Then what I want to do here, you can have the logic as per your own requirement. You can change it. This is a simple insert query. Insert into CDC and this table CDC, this JSON split data underscore CDC underscore CDC means this is our audit table. Operation type, event ID, parent ID, item ID, whatever you want to insert. And here I am taking this. If you see the value new dot event id, new dot parent id means we are going to take insert means what record should be new, right? Then update. For update also, whatever query, whatever logic you want to keep, you can have. Here if you see I am saying old dot. Old means I'm just comparing, and then I want to keep the new attribute value and old attribute value means if this was updated, then what was the new value and what was the older values. Then I can have identify means I can identify easily. Okay, this was the previous value and this is the new value which has been updated. Like that, you can keep for another columns as well, where you want to maintain older previous data also and new data also. Then this is for delete. For delete also, for delete everything is going with the old only. Okay, return old and if so, you can have this else if else condition where you can have your comparison with the older data and new data, whatever you want to put, you can go with this. And then you once that is created, then you have to create a function for each of the operation. Again, either you can have a combine or you can have a separate. So here I have the separated one. Create trigger, this is for insert, and this is to this table. So this after insert on CDC JSON split data, this is the main table. So this is going to work on the main table. For each row execute procedure, and this is the changes. Where is this changes? This changes is above this one, this function. So this function you are going to call in your triggers. So you should have function for insert, update, and delete, and then you should have trigger. So this is the trigger. Again, I am creating one trigger for update and one trigger for the delete. That's it. Then you are done. So simply I will be running this create function. This is done, and then trigger. Let's run for insert. Then let's run for update and then delete. All is done. Next, I will just verify this once. If you see here this table, if I go to this table, Nothing is that this is a simple table. This table was also simple table only, but as I created function and triggers, here you can see this has captured automatically. Okay, that this is what I have created, table triggers. And you can verify from here. So this is looking for, this is the logic for insert, this is for update, and this is for delete. Where this is calling this function for each row procedure, this is the function name. Okay, log JSON split data changes, and then this is going to work accordingly. And then we are done. You had to create a function, you had to create triggers for each one, and nothing is required next. Simply, I am going to insert data again here. So before inserting the data, I will be test printing this data one more time. Select the star from. Let me run this and I will capture the output. So let me take it here. Then I will insert the data again. If you see what is here, I have 1 and 2. I do not have anything for 3, right? Third file is not there. Parent ID 1 and 2 is there. Now I am going to insert with 3, parent ID 3. Let me run this. Again, I will run the same. Okay, already I have given here one of the syntax. If you see, 3 and 3 is inserted. What is expected in the CDC table? As of now, we have not loaded anything there, right? Just we created the trigger and function. But let's verify that as well. Here, let's verify the CDC table. Do you see something? We just inserted new record, right? And what was the event ID for that? So event ID was 9 and 10, and parent ID was 3, item ID was 3. This is the file name. This is whatever column we have defined, we will be getting all the things. Okay. Old attribute, here it is null because this is not about comparing anything. This is not checking about the update, but it captured. Okay, that this is the load timestamp or means data load date wherever it is happening. And then here change timestamp. This timestamp is for changing one. Whenever your change capture is happening, the format you can change whatever you are looking for. As of now, this is coming with the time zone 5:30, but you can make it simple. You means you can remove the time zones and all. Here operation type. This is insert one. So like that, if you have to check out what was inserted or what was updated, you can verify from here and then you can process for that particular file only or particular record only. Then do the update. This is for update. Just I want to update. Okay, let me run this one more time. Then we will go for this. So you see the update. Sorry, insert, new insert. Now I'm coming to update. For update, what I'm doing? Update this data table, then attribute value equal to this, where parent ID is 3 and item ID equal to 1. Where parent ID is 3 and item ID equal to 1 means this record. What it is saying, attribute value equal to updated test new. What is attribute value as of now? Attribute value is test new. But we are going to get updated test new. This is the expected one. Let me run this. And I have one more update. So this update is for second record where we are going to expect updated test device data. Let me run this as well. So we inserted 2 records for 3 and now we are updating the same. Then verify the changes. Here, let's run this. What do you see here? This is to update, right? And for the update, this is also for the 9 and 10 only. For parent ID 3 and item 1 and 2, because for both we did in different steps. And here, this was the previous data, test new and test device data. And this is the updated attribute value, updated test new, updated test device data. So like that, you can get the updated one. Then next is delete a record. So for deleting a record, so you had a look for insert and update. Next is for delete. So for delete, let me delete this as well, where again I am working for parent ID 3 only. I want to delete the parent ID 3 and first row item ID equal to 1. That means this record. This record we want to delete. Let me run this and then verify the changes. And now you can see operation type is delete and this has deleted for parent ID 3 and item ID 1. Let's verify the main table. Here I will be taking this, select the star from this one. Okay, for 3 we had inserted 2 record, but now you can see 1 record only because 3 parent ID 3 and item ID 1 that has been deleted. Okay, and that delete has been captured already. If you see the update has been captured here. See, you see updated test device info, right? And first also we had updated, but we deleted. That's why we are unable to see. But this one, so updated one is there, deleted also already gone. But you can capture those things in your audit table. So like this, you can set up. And again, as we have already created trigger, we have already created function. So that is one time activity only. We are good now. And as longer your table is available, your CDC table is available, that step is not required to repeat anytime. Then here created as source storage and what I want to do here and okay, just this is just to explain this table is created to store changes either for insert, update or delete from the main table, whatever your main table is. Here I am considering this as main table where our all the data will be uh, means our insertion is happening from the source and this is our audit table. And then trigger the function. This is the function we created where we are handling logging operations like either insert, update or delete. And if we have any specific logic, we can mention in our query. And then triggers are added to capture and logs changes for all the operations where we can have the trigger for insert, update and delete, and that will be capturing all the things. Above, in the above example, we had the combine function. Here I have defined the separate. If you, let's say you want to create for insert only, you are not caring for whatever updated or deleted. In that case, of course, you will not be going for all, right? So let's see if you have to create single only. So this is for the insert. In insert, I'm just creating a trigger name, sorry, this function name by insert. And then here I am giving the logic, whatever logic I want. Means this is the insert query and how you want to insert, you have to give that. Then uh, function for update. So for update also I am creating a separate one and for delete also I am creating a separate one. So above we had the combine, here we have the separate. Now creating the table. Here, sorry, creating the trigger. Here trigger is already separated. For this one, I am creating version 2 because already one trigger is created on this table. If I will be creating with the same name, that will fail, that this already exists. So either you drop that first trigger, then you recreate, or to avoid failing, here I have given underscore v2, so you can follow anything, whatever you are looking for. Better practice is you can drop and you can recreate. And then again, you can do the testing. Here I have okay, if you want to drop the trigger, then here I have mentioned the steps. You can drop trigger name, then your table name. You can say, okay, these are my 3 triggers I have created, insert, update and delete. And this is on this table because all the triggers and functions we are creating on this table only, right? Main table. So you have to provide that. Then drop the function. We created one function also. That function is having that all the triggers are working with that function only. So you have one, you have function, you have trigger, you have to drop that. Then here I have captured another CDC example. Okay, you can practice that. This is with the another sample data. where I have worked with some simple things like employee ID, first name, last name, position, salary, had a department and all. Here also steps are same. Creating one of the main table, creating one of the audit table in the sense CDC table, then creating function, creating triggers, and then test that. Test by inserting new records, test by updating the data and deleting the data, and then go to the audit table, CDC table, and verify whatever happened. And you can do that. So, did you understand this, or do you see any challenges, any issue? Any comment from anyone?
I need to go through this.
Hmm?
I need to go through all this.
Okay. So simply, I wanted to tell you that in the real time, always data will not be kind of straightforward. That okay, data is coming and you are processing. Data can be something like this also, where data is keep on coming with some changes, but not all the data is changed. Not all the data are updated, or maybe some data is the older data only, some data are the new, either with update or without update. And in that case, if you have to just process the data, then blindly if you are processing that, okay, select a star from table and apply the transformation. In that case, let's assume that if you are having some lakhs of records, unnecessarily this will be taking lots of time, right? That is going to block you. And if only 10 records are new, if we are comparing from the yesterday, including update and insert, then you can identify and you can process only those 10 records. Then you are not going to process that 9,900 whatever is the remaining. You are saving lots of time because you compare that you are reprocessing 1,000 records, and parallelly, you are processing only 10 records. 10 records can be done within few seconds, right? But for 1,000, maybe this is going to take few minutes, like 10 minutes, 20 minutes, 30 minutes, whatever. It depends upon the data and transformations and all. What kind of transformation is there? So accordingly, that will be taking the time. So it's a good practice that you can identify and you can process only the change data. That's why we have the concept of CDC, uh, change data capture, and that you can do either with the SQL. If you are working with SQL, then you can enable this. So here what you can do, let's say you are having an audit table, and in that audit table you are capturing all the details, right? That either that is update or delete. So based upon the insert, update and delete, you can identify the records, and for that record only you can process. So let me go here. And I'm getting okay. These are the new insert and these are update. And let's assume that in my this JSON table, multiple records are there. So if I am getting these are the update, these are the delete, and this is the employee ID. Okay. Or this is the event ID, whatever column we have for the identification. For that only we can filter out from this table. Okay. Like from this table, filter the data based upon this employee ID because we want to process this only. So we can have that segregated, and accordingly we can focus on processing those specific records only instead of reprocessing all. Or in the main table itself, you can have a column, let's say update flag. You have a column update flag, and in that update flag you can have a value, let's say I for insert, update, you for update, and let's say you are mentioning D for delete. So you can have something for your identification. If the data was inserted, then keep I. If updated, then keep U. If deleted, then keep D. And then based upon this update flag, you can identify and then you can reprocess only the required one. How you can do this? Let's say if you're working with the SQL, then you can build up your logic around this and you can try to populate this column. Okay, or you can directly go with this. Or let's assume that you are not working with SQL and Still you have to do this. Then this is a workaround with this Spark itself. Like either you go with the versioning with the Delta Lake, if that is available to you. If not, then you have to write your own function, your method, that how you will be capturing all those updated and deletes. Means simple, you are going to compare the data, and based upon the comparing you will be getting either that was updated or not, that was deleted or not, and then you can populate this value. But make sure that whenever you will be doing comparing, that is going to take lots of time. How you can test that? uh, Here, whenever we are doing the insert or update or delete, this is not taking time. Within second, this is keep on updating this CDC table also, because this is internal architecture with SQL, and this has been defined in a way that this is really optimized, and this is completely and there is no external dependency, right? This is completely independent system. So as soon as you are doing anything, any activity is happening on the main table, immediately this is uh, keep on updating your audit table as well. But let's assume that this data is keep on changing using the PySpark, and this is not integrated with your CDC, or you have not enabled your trigger and function. You want to simply handling using PySpark itself. Then what is your option? Your option is read the storage data, means store as in a data frame, and compare with today's data. After comparing only, you will be getting either this was updated or not, this is deleted or not, right? Then you can do whatever you want to. But can you assume that if you will compare, how much time this will take? Also this is comparing only. As soon as you are deleting or updating or inserting, this is quickly comparing with this table, and it is identifying what is insert, what is update and delete, and this is doing quickly, very much quickly. It is too much faster. But if you are doing with manual intervention with PySpark and all, then this is going to take lots of time, because if you are having 1,000 records, this will be reading all 1,000 records. You are going to compare, then you are going to do something, some transformation over there, some checks are there, and then you are going to insert the data. So if you are not doing anything also, even only for read and write only, this is going to take some time. Some time will be reserved only for the reading writing. Okay, so that will be costly. So if you have database option, you can always choose this one. And if you have a Delta Lake option for the data versioning and all, you can choose that as well for enabling CDC. And if you have maybe some other third alternative option, you can always check. If nothing is there, then only you go with the manual thing, like okay, I will write my own function in Spark, and then I will be doing the comparison, I will be doing the checking, because always that is a very costly operation, and that is going to take lots of time. That will be a heavy challenge for you if you are dealing with the good amount of data. So that will be a challenge, and then you have to resolve that. And in very recently, I had faced this challenge in my real-time project as well, and we had resolved around the database. But why database? Because we were working with database. Uh, that's why we use this. But always database is not the option. So we have to go with the alternative. So this is just one thing what I explained, and this is for interview as well. In interview also, you can have a question. If incremental data is coming or data is keep on refreshing every day, then how you are capturing what was updated, deleted, or means how you are capturing the changes and all. Then this is the thing you can explain. If someone is asking how you do this, then you have only two things to tell, that you are having one main table and you are creating one audit table, and for capturing all the changes you have to create a function, and then you have to create a trigger. That's it. Means creating audit table, creating function, and creating trigger. Nothing else. No fourth option is required. And for trigger and function, you have all three options: insert, update, and delete. This is optional. Either you can go for any one or you can go for all three based upon the requirement. Whatever logic you see I have mentioned in the insert query, that is flexible, and it is up to your requirement, your business logic. Okay, this can be means you can change it as per your logic. Maybe you need very few columns only. Let's say you are having 100 columns in your table. 100 column is too much. Let's take example with 20 column only. You are having 20 column and there can be some updates over the columns, but you are caring only for 2 3 columns. If these 2 3 columns data is updated, then you want to do something. Otherwise, if any other columns are keep on updating, you are not caring for that, means that is not affecting, there is no impact by that. Okay, if there is no impact, you do not want to care. In that case, why you will be checking update for all the columns? No, not required, right? You will be simply creating the your audit table with those selected columns only, 2 3 columns, whatever you want to check, and then keep the check the updates. If that is if any update is happening on that column, then it is okay. If any other columns are keep on updating, just ignore that because that is not in your requirement. You are not looking for that. There is no check required like that. So this is always flexible. So you can remember this thing, these three things only. You are having one main table. On that main table, you have to create the function, you have to create the trigger, and where that triggers and functions will be working out, you should have one audit table as well. And this is the audit table where all the changes for either whatever the event is, that is insert, update or delete, that will be keep on inserting here automatically. You are not going to do anything manual here. Okay, so that's it. You can have your exercise with database and you can have your exercise with Spark itself. PySpark means just forget about database. You think that you do not have database where you are having this ADC table. You want to capture this insert, update and delete with your own function, with your own logic without having this trigger and function in the SQL, which is inbuilt with the SQL. Okay. Here I will be coming to this code and I will show you something. This is TB data integration. Even this code is copied in the file. Here, whatever I'm doing, this is very simple thing. I'm not doing much, but you can include in your exercise. Here, if you see, I'm just doing insert implies. In that SQL, we were inserting with the SQL query, insert into table name, right? But let's assume that you are working with PySpark and you are doing that insertion, updation, deletion using the PySpark code and not using your SQL query directly. So here this is the manual thing, but you have to automate it if you are working with the real time where employee data will be coming with your source data and column as well, and then accordingly you can have the changes. So this is for just I'm trying to insert employee data equal to this. I'm keeping some manual data. Then column equal to this. This is my column employee ID, first name, last name. And this code is depending upon the this example, another example which I have not created yet. This is the employee table. If you see here, this one, employee ID, first name, last name, position, salary, head and department. Okay, so let's assume that I have created this table, then I can do the insertion. Accordingly, I have mentioned the data here, and then this will be inserting the data. Here you can take either you want to do overwrite or you want to append, whatever. And then this is the update employee. If you want to insert, if you want to update, if you want to delete, accordingly you will be having the logic and that will be. So here in this function, this is integrated with SQL only because I am working with SQL and I'm only inserting, updating and deleting through this PySpark code. Okay, but this will be keep on capturing all the details, all the event changes because my trigger each created. I'm just assuming that I have created the trigger, I have created the function. So this will be capturing. This is capturing very easily insert, update and delete. But what if my trigger and function is not created or I do not want to create? Then how you will be identifying insert, update and delete? That is what you have to explore. Explore in the sense you have to write your own function. Then you can compare the data. Either you can compare or you can think about something else, whatever can be more better. And accordingly, you can populate the trigger flag means a flag for the either data was inserted or data was updated or data was deleted. You can identify and then you can populate value for that. And if you are going for the POCs and all, always make sure that you are following the good practice. Good practice in the sense define the function, have the parameterized, make the code reusable so you can use multiple times. And if let's say today table name is employee, tomorrow it can be employee data. Day after tomorrow it can be global employee. So if table name is changing, database name is changing. So our code should not be kind of there is nothing to be changed in the code directly. Make it configurable, make it generic, so we can change only the parameter and that should be working for us. Okay, so like that you have to work on this. Why I said this, because reading and writing from the JDBC is okay. You can simply say that this one, if you see here, okay, like here this is the right employee df dot write dot jdbc. This is a simple write. You can do the write, you can do the read. That is not complex. This is a simple thing, but in real time you are going to face the challenges as well. That's what you have to do. Okay, that along with read and write, reading the data from the database, writing the data to the database is okay. But what can be the challenges? Challenges can be either handling the use case for the insert, update, and delete. As I said, that is one thing. And second thing can be, let's see here, what can be the challenges. One thing can be track the changes on data. Second thing can be, let's say you have some 20,000 records in database. Then 20,000 is a very less count, but just I'm giving because you are going to do a POC kind of manual thing, right? So let's assume that we're having 20,000 records and your resources are not supporting this, means that much resources are not available. Let me make it a little more and have this count something 2 lakhs. Okay, so 2 lakh is the count in the database. I want to read that in the using Spark, and then you have to upload this data as a Parquet file. You can plan for 10,000 records, 10,000 records for each batch. So read this 2,000 records from the database using your PySpark in the same at a single time only. Keep on reading in the loop, and in each loop you fetch the 10,000 records and you save as a Parquet file. This is one thing for the single loop. Second can be, uh, let's assume that your system is not supporting for that much because this is 2 lakhs. Let's assume that 10 is appended now. So now data is too much. Okay. Then what you can do, you can try to read something 1 lakh, 1 lakh record at a time in batch. And then next time it should be started with 1 lakh plus 1, right? Up to 2 lakhs. You have to read. So like that you can plan out. You can build up a scenario, you can build up a POC where just load the data into the database manually. You can load, or maybe automatically also you can load. You can create the data and you can load into your database, and then you can do the POCs, how you can keep work with the keep on tracking the changes. And second thing is, if you have bulk data in the database, then how you can handle with the PySpark. How if you are planning for the batch read, then how you can do, either you can do with some small batches, or you can read at a time and then you can iterate for the small batches, and you can do whatever you want to, means apply the transformation but not all together, apply over the small batches. Fine. Any question here, or you want to have any comment? No? Good for all. Om Prakash, did you get it?
Yeah, Anamika.
Okay. What about you, Chandan?
I will go through once. I will let you know. I have any question.
Okay. Okay, fine then. Then I'm expecting that you will be doing this. This exercise document I will be sharing with you people. This one I was sharing, right? This CDC change data capture where all the script is there. Even this Python example is also attached here. And I will not providing the code. I will just mention the use case, what you have to do. Then you go through that. And if you face any challenges, then we can revise that. We can look into what is the challenge and how we can resolve that. Challenge in the sense this one. You have the data, then you read all the data and loop into the batch and then say by Parquet files, Parquet or CSV, whatever. And then let's assume that you have lots of files in the source and files or data, you can say lots of records are there in the source table, and then you have to read the data in batch and not all together, because just assume that your Spark resources are not supporting, that is not how much you are required. Let's say you are having some 1 terabyte of data here in this table. As of now this is having 32 KB, so this is very small volume. Just assume that this is 1 terabyte. If your Spark resources is not for that is not okay for 1 terabyte, how you can process? You can't process. So you can process in a small chunks, small batches, and that will be uh, good to run, good to complete that process and all. So like that you can plan. So I will be mentioning some 2-3 lines for each of the things, for each of the use case. And I believe that you can create the data manually. If you can't create, then previously I had shared one code to generate data automatically, means in dynamic data. If you have that, then it's fine. Or even from multiple online sources also, you can have some dummy data and you can work with that. Or if you can insert manually, then that is also fine. You can repeat the same insertion. Like let's say you are having some 10-20 records, you can run that for 10 times, 20 times, then you will be having some good number and then you can work accordingly. Okay, all good. Fine then. If you have no question, then we can wrap up the session. And before that, make sure that you are having this SQL setup and just practice once, so you will never forget. And then this series is really very much important. In interview also, this is a good point. Even you can mention in your roles and responsibility also, in your project details as well, that whatever you did here and what was the use case. So this is going to have a good impression that okay, you have handled these kind of activities as well. Okay. And then we are going to work with Kafka. So for Kafka, all the setups and all, I will share over screen share itself how you can do that. And then once that is done, then you can go with the exercise for either for the real time or for the batch data. Okay, fine then. Let's meet tomorrow. Have a good day. Bye.
Bye.
Bye.